One of the most requested videos on this channel has been to build an inventory system, so here we go. Today we're going to procedurally build the view for this inventory system that allows item drag and drop. It will display a stack indicator, and it's going to allow us to drag the entire panel around the screen. And we're going to do it with UI Toolkit, but using code, not clicks in the UI builder. We're going to look at two different ways of doing drag and drop using UI Toolkit. The second way is going to be to implement a UI Toolkit manipulator. Lots to do today, so let's get started with a high-level overview. Let's start by taking a quick look at a diagram here. So I've got a setup very similar to the video from 2 weeks ago about MVP MVC. So I've got a view, a controller, and a model here. In the Unity editor, we're going to expose the entire system through a mono behavior called inventory that'll access straight into the controller. The controller is going to have two-way access to the model and the view. So the model and the view are going to publish events, and the controller will make all the decisions about what's going to happen in the system. I want to design my system in such a way that there are clear seams in between each of these parts that really should be its own little unit. And we're going to focus on one of those units today, which is the view. I want to build this system in such a way that in the future, if I decide I don't like UI Toolkit anymore, I want to use UGUI again, or I want to use a better system like Nova, I should be able to replace this entire view module with whatever system I want. So today we're going to focus on just this one little area of the view and procedurally build our UI and everything it needs for the drag and drop functionality. Today we're going to build everything with code, but if you want a primer on using the UI builder that comes with Unity, I'll have a link to this excellent video from HJ at UI Motion Video in the description. Now we're still going to need an empty XML document to act as the root of our visuals, so you can get a new one by going to Create, UI Toolkit, UI Document. I'm just going to call mine Inventory, and then I'm going to open it up in Writer. If we take a look here, you can see that there's quite a bit of metadata associated with this UXML, and most of it is unnecessary. This default document also has a namespace of engine. If we jump over to one of these samples, this one comes from QuizU. They're using a namespace of UI and have completely different metadata. Now, we could actually go with the bare minimum, which would look something like this. Now here, I don't have a namespace at all. So I think what I'm going to do is actually jump back to my inventory UXML document, and I'm just going to strip away pretty much everything that is unnecessary. We're not building an editor tool, so these lines here can go. We can bring this up a line, and we can get rid of the XML version declaration. Now, unless you're going to use UI Builder, you will never make changes to this document again. We're going to do everything procedurally and just use this as the root. Now, if I come back into Unity here, I can go onto my empty inventory game object, and I'm going to add a new component. And that component is going to be a UI document. Now, you can create your own panel settings asset by going to Create UI Toolkit Panel Settings Asset, but I've already got one, so I'm just going to choose mine with the selector. And we also need a reference to the UXML document that we were just working on. For every UXML document, you probably want to also have a style sheet. So you can get one of those by going back into the Create menu, go down to UI Toolkit again, and select Style Sheet. Now I'm going to call this the same name as the XML document, and I'm going to open it up in Writer. So here we can see it just has one element defined with no style at all. Now before we start writing styles, and since we're not using UI Builder, let's just make a little diagram of what we expect to accomplish. So let's draw out all of our visual elements one by one, starting with the ones closest to the root. So at the very back of this pile, I'm going to have a container that'll just stretch the entire width of the screen. And then as a child of that, we're going to have our actual inventory. Now the inventory is going to be between the container and all of the slots. So we'll be able to put a background image on it and whatnot. But absolutely positioned over top of this inventory, I want to have a frame and another little background image with the words inventory on it. So we'll have a frame, and I'll make another one. I'll just label it here as header. The header can be its own visual element, but we can have a child of it that is a label, and then we can easily change the text of it. So I'll make one more visual element here that will represent our slots container. So it'll just be basically a wrapper container around all of the slots and help them get positioned properly above the rest of the inventory visual elements. Each slot is going to have to contain a bit of logic. So it is going to extend a visual element and be its own class. And that's just because all of these other ones are kind of dummy. They're just placeholder stuff for positioning and style. The slots themselves need to contain a bit of logic so that they can react to pointer events. I'm just going to stack these up here in the view in the order at which I expect them to appear in my tree. And this will make sense as we start to procedurally assemble this whole tree-like structure of visual elements. So the slots will sit at the very top here, but there's still one more thing that we want, and that's a little icon that we can drag around. So once we've selected something, we're going to make a little ghost icon that will be most of the time invisible. But once we've made a selection for dragging one of the slots around, we're going to fill it up with an image, and then we can drag and drop it as necessary. The storage view is going to be the basis of this system. It's going to have an array that's going to represent all of the slots within this particular storage unit. Now, today we're just working on inventory, but in the future we're going to have more. Now, it's going to need a reference to the UI document component as well as that style sheet that we created. Next, I'm going to have some references both for the root and for its child, the container, just so it's easy to make queries later. It's nice to have a reference to these top-level elements. Next, I'm going to create an abstract method here that will be responsible for creating our tree of visual elements. And I'm going to pass in an argument with a default size of 20. Now, I know already the inventory I want now is 20, but if I use it for my hotbar later, I might want to pass in 10 or 6. For now, I'll kick this off with a coroutine in start, but in the future, I'll run it from the controller once the entire inventory system has been wired up together. That's really enough for our storage view for now. Let's extend it with the inventory view class. So let's get rid of this red squiggly here by implementing the initializeView method. Now, the initializeView is going to do everything required to set up the visual tree for us and initialize our slots. Because we're going to have a label at the top of this particular panel, I'm just going to expose it as a string to the Unity editor here with a serialized field. As a first order of business here, let's just define our array as a new array of the size that we've passed in. Now from our UI document, we can get the root visual element and assign that into the root variable. And I'm just going to run root.clear here. That'll clear it out every time we decide to initialize the view, in case we're running it multiple times for some reason. We're also going to have a reference to the style sheet, so let's apply that to the root. Now we can begin constructing the rest of the tree. So we'll start with the container, the one that's going to stretch all the way across the screen. I'm going to use the extension method createChild. Now, this extension method and several others that I'm going to use have been discussed thoroughly on our Discord channel that you're welcome to join. I'm sure we're going to have lots more interesting conversations about UI and inventory systems there. Why don't we go and take a quick look at those extensions right now? The main purpose of all of these custom extension methods is to make it so that we can chain methods together and have less code going on when we're constructing things procedurally. So we're able to create children and attach them to parents. I have two methods for that. One is specifically for visual elements and one is for any type T. We're also able to add a particular child to a parent. We're able to add a CSS class style to a visual element. And if we scroll down a little bit here, we can also add a manipulator to a particular element. We'll get to manipulators towards the end of this video. All this code will be in the repository for you to have a look at afterwards as well. Let's keep going and make the first child of our container, which is going to be that inventory backplate. So we can create a child on the container and we're going to give it the style inventory. The inventory is going to have two children, which will be absolutely positioned. That's the frame. And then on top of that is going to be the header. The header is going to have its own child, which is a label. And the label will have that panel name of inventory. Next in the order will be the slots container. I'm going to make it a child of the inventory and give it a style called slots container. Now we can iterate over the size and we'll create a new slot that will be a child of the slots container. Slot is a class that extends visual element. Now, it acts just like a visual element, but it's going to have some additional logic for us. We'll give each of these a class of slot, and then I also want to keep track of it in my slots array. Now, we're almost finished building our tree. If we take a quick step back and just look at this whole thing, you can see that we're assembling it bit by bit with one thing becoming a sibling or a child of the next thing. And we're giving most of these things their own style name. We're going to get to styling in just a moment. Now let's have a look at this slot class that extends visual element. I need each slot to know a little bit of information, but it doesn't really need to know much about an actual item. It needs to show pretty pictures to the user so they can click on them and move them around. So it needs to know an image to show, and I'm also going to show a stack label. So if we're stacking items and we have a count that's greater than 1, I want to be able to show the user how many are actually there in the slot. Next, I'm going to make use of the index of method that exists on visual elements. And since every visual element also has a reference to its parent, and this parent, being the slots container, only contains slots, the index of method is actually going to give us the correct number of this slot within the slot container. So the first one is going to be 0, and it'll go all the way up to 19. Now, for convenience, we're also going to pass in a little bit of data about what should be shown here on the screen. The first is a serializable GUID that we're going to get to in the next video, just representing the type of item that this is. The other is going to be the actual sprite that comes from the item details as well, and that's because image and sprite are not really the same thing. I need to apply a texture from the sprite onto the image, so it's useful for me to store a reference to that here. So in the constructor, I can create the other visual elements that we need. I'm going to create 3 of them here, but I only need references to 2 of them because the one in the middle is the slot frame. That's going to sit over top of the image, but underneath the stack count. Now, finally, we need a way to actually set this from the controller so we can put our dummy items in here for testing. And we'll, of course, during runtime, we're going to be wanting to set and unset this as well. So we'll just have a method here called set, and that'll accept our serializable GUID, the sprite, and the quantity should it be different than 0. So we'll set the item ID and the base sprite. That's the only data that we really care about. Then we're going to set the icon image. If the base sprite is not null, let's get the texture from that. Otherwise, it's null, no image to show. And then we can say the stack label text, if the quantity is greater than 1, let's put the quantity in there, otherwise empty string. And then we'll decide if it's visible or not, also based on whether the quantity is greater than 1. Now, we should also have a method just to clear this out, and all that needs to do is set the ID to empty and set the image to null. That's it. Now, we should probably do something about our ghost icon too, because we're going to want to apply a little bit of styling to that as well. So if I come over here to the storage view again, let's just have a static visual element that will represent the ghost icon. Now we can initialize this when we're initializing the rest of our tree. So back here in inventory view, I'll just add one more line so that we can have this ghost element be initialized as a child of the container. And I'm going to give it a style name called ghost icon. I'm also going to use the bring to front method. This method makes sure that a particular visual element will be in front of all of its siblings. Okay, so we've got our whole tree constructed. Why don't we have a look at it and see what it looks like without any style at all? So back here in Unity, I need to add that inventory view to the inventory game object. Once I've got that in there, it needs a few references. The first one being this UI document. I'm just going to drag that reference in there. Then it needs a reference to that empty style sheet that we're going to start filling up. Now, additionally, I also need the inventory component itself that does all the wiring up of the controller and the model and the view together. And that's going to provide our starting items, which I've already created quite a few here. So I'm just going to drag a bunch of them in here. And I want a couple extra ones just so we can test the stacking as well. Maybe I'll grab one more mushroom too. And that should be enough to get us started. But what happens when we press play now? Let's find out. So all of our items showed up in a nice column. That's great, but how do we know without any styling that this structure is actually correct? Well, Unity actually has a tool that is quite good, and that's called the debugger. Within the debugger, there's a button there called Pick Element, and I can choose something from the screen to have a look at. So now I've selected my entire tree here, and I can have a look at the exact structure of it, where the classes are applied, and I can break it all the way down here, right down to the stack label. So it looks good. I can see my ghost icon way down there at the bottom. Since this looks exactly what I had envisioned, let's start applying a little bit of style bit by bit. Just by way of review, let's come back to our UXML document. You can see there's nothing in here still. It's just the root. There's nothing else and never will be. Now, over in our empty style sheet, let's start working our way from the very bottom, which would be the container, and we'll go all the way to the topmost element. So the container is going to cascade its styles down to everything else. So I like to put things that I'm going to generally want set everywhere in here. Let's flex grow 1. We want the width and height to be auto, no maximums. Well, I'm just going to have the column will be the default. We're going to justify everything vertically and horizontally into the middle. I've chosen a font that came with this asset pack and referenced it here as our default font for everything. I'm going to drop a little shadow, and then I've also chosen the color yellow. You can see in the column there, Writer is showing me what the colors are as well. Now, I'll go on to the inventory. The inventory is going to show our background, which is a nice wooden panel. I want it to be a fixed size. For me, I know that I want this inventory to be 300 pixels wide and no more than 500 pixels high. I've added a little padding there just so I can keep the contents away from the edges. Let's go have a look in Unity. So we've got our wooden panel showing up. We can now see the words inventory there, even though it's in the wrong spot. But you know what? It looks not bad. Let's keep going here. Let's do something about that text. So for the inventory header class, I'm going to position it absolute. I already know exactly where it is. Now remember, absolute positioning is relative to the parent, not the whole document. So it's relative to the inventory, not the container or anything above it. So I know the positions. I want it centered. I've got a nice background image I'm going to put under this. And now take note of the last thing here, the Unity slice scale. When you're using 9 sliced images, they may sometimes look wonky if they're too big to fit what you're trying to do. You can scale them down or up using this attribute. Now I'm going to add one more thing here for the label. I want the text to be bigger. Let's check it out. Now notice I'm still in play mode. I never came out of play mode. I just come back into the editor and hit Control R. I can see my changes in real time. That's one of the beautiful things about UI Toolkit. So that's looking pretty good. Well, let's keep going with the styling. If I come back in here, I'm going to add the inventory frame. No surprises here. It's almost the same as the header, just a different image and different dimensions. Let's do a quick check. Control R. That looks pretty good. Let's move on to the slot container and the actual slots. The slot container needs to be down from the top a little bit, so I've added some padding there. It needs to wrap and it needs to go in rows, starting from the top left corner. So that's why I've got flex start on the align items and justify items. Now, each slot I know I want to be a specific size, and that is 60 by 60 with a margin of 4 around them. Each slot has a frame on top of it that needs to be positioned absolutely. It's the exact same size, positioned from the top left, and I already have an image to go into that. And next down here, we have the actual slot icon. Now, I'm not going to specify a size. I just want it to fit into the slot. Now, the frame that came with this GUI asset has little rounded corners. So I want to add a little bit of padding just so that my images of my icons don't stick out past the frame. But when we pull them out of there, they won't have the padding anymore. So it's going to look kind of cool if they're just a little bit bigger. Let's have a look at how we're doing so far. Well, that looks like a real inventory panel now. It's not too bad. Of course, we can't do anything with it. There's no drag and drop yet, but we'll get to that in just a moment. Before we start doing the drag and drop, let's make sure that we've got proper styles for everything else. So the ghost icon needs to be the same size as the slot. I'm just going to paste that in here. It's an absolute thing that we're going to drag around and change its position of. We'll start it as hidden. Let's also put in the styles just for the stack. The stack count is also going to be absolute, but it starts in the bottom right corner and it's going to be over top of that frame and just needs to be a little bit smaller size. So obviously it took me a little fiddling around to figure out all the numbers and positioning and sizes and everything, but with the runtime changes, it's really not so bad. We won't be able to test either of those last two styles until we've implemented drag and drop. So let's move on to that. So back over in the storage view class, I'm going to add 2 more fields here. One is a Boolean to say whether we're dragging or not. The other one will store a reference to the slot that is being dragged around. Now, all visual elements allow you to register callbacks. So I'm going to register a callback here on pointer down events. So when the player clicks this slot, I want to publish an event. That event will publish the location of the pointer, and it's going to let us know which slot actually got clicked. To fire this event, let's write the onPointerDown method. Here we can say if it wasn't the left mouse button or the item ID is actually an empty GUID, let's return early. Otherwise, fire the event, sending in the position and a reference to this slot. Finally, let's stop propagation on the event because we don't want other elements in the tree reacting to this particular event. We've already handled it. If we go back to the storage view, we can listen to those events here. So in our start method, why don't we register a listener for each of the slots? I can just have a for loop here and I'll register each. Now we'll have a method that will handle it when one of the events from a slot gets fired. We'll call that onPointerDown. So onPointerDown will handle both of those arguments, the position and the slot. So in here, we can do all of our logic to kind of transfer the information from the slot into the ghost icon. So we'll set isDragging to true, and let's set our original slot to be that slot, just in case we need to kick back to it later. I'm going to create a little helper method here that will help us move the ghost icon around. Remember that it's absolutely positioned, so I have to move it by its style. So let's use that method here. Now that we've set the position of our ghost icon correctly, we can update its background image to be the texture of the sprite. We can set the original slot's image to null, and we can hide the stack indicator. Finally, let's apply a little bit of styles to the ghost icon. We definitely want it to be visible, and we could make it a little bit semi-opaque, but I think I'm going to play with that for a little bit first and see if I actually like it. And it could actually go into the style sheet, to be honest. There's still 2 more events to handle. That's moving around, and what are we going to do when the player actually drops the item? We don't want our view making any logical decisions about whether or not an item belongs inside the model or not. So what we're going to do is publish an event with the original slot and the destination, the target slot, and we can have our controller listen to that and it will make the decisions. So we got that event there. Now we can't register these callbacks on mono behaviors, but we do have a static visual element here, which is the ghost icon. We can register callbacks right onto that. Since we have a static reference to the ghost icon here in this class, we can also handle any events that it catches right here in this class too. So let's scroll down a little bit and we'll have handlers for onPointerMove and onPointerUp. Let's do the move one first because it's pretty straightforward. If we're not dragging, bail out of here. Otherwise, let's just update the position using our helper method. That one's straightforward enough. OnPointerUp is a little bit more complex. I'll just give myself a little bit of room here. Again, if we're not dragging, there's no reason to be inside this method. Let's bail out. Now we're going to use some link to figure out which slot was actually closest to our drop point. Visual elements have a property called worldbound, and we can use the method on those, which is called overlaps. This will get us an IEnumerable of all the slots that are overlapping the ghost icon. We'll put those in order by closest to farthest away, and then we can get the first or default. That'll get us the closest slot to the drop point. Now, as long as that wasn't null, we can actually invoke our event because we know what the original slot was and we know what our target slot was. That's going to be the closest slot. If we're not going to invoke that event, let's just reset our original slot's icon so it's as if nothing happened. It's like maybe we dropped it off into nowhere. Now, we can turn off dragging. We can also set the original slot back to null. We don't need it anymore. And we can hide our ghost icon. I think it's time for a little test. If we come back in here, reload the domain and press play, voila, let's see. Okay, yeah, mushroom comes out, squid comes out, mushroom stacks, and we see 2. We can stack it up to 3. I can swap that one with the bones. Let's see. I can swap these, swap those. The squids, yeah, nothing's really going to happen there. In my dummy item details, the mushrooms are the only ones that are allowed stacking, so that's why it's behaving that way. The squids will just swap with each other. Okay, last thing to do is to be able to move this whole panel around. Let's take another look at these extension methods. Now, the with_manipulator extension method is just running the add_manipulator regular method, except it's going to return us the visual elements so that we can actually chain this together. Now, in order to use it, we actually have to create a manipulator. This is actually a lot easier than you might think. So I've created a class here that inherits from pointer manipulator. What this is going to let us do is use all of those callbacks that we are registering for on visual elements before, but we can wrap them up in a nice little class like this such that it becomes a little mini state machine. I'll just import the missing members here, which are to register and unregister for callbacks. I'm just going to paste these right in here. We want all the 3 same callbacks that we were using for the drag and drop, except this time we're going to have them in a nice little package here. The target is going to be whatever we apply this manipulator to, and that's going to be the inventory panel. Manipulators also have something called an activator, and I'm going to create one right now. An activator is a condition upon which this manipulator decides whether it can work or not. Here, I'm just going to add one activator, and that is a filter that determines whether or not the player has clicked the left mouse button. Now, there's all kinds of activators you can use. This is simple enough for this example. We're going to use it in our first callback here. So let's start with the pointer down event. I'm going to add a couple fields as well just to track things while we're moving the panel around. That's a Boolean for is dragging and a vector2 of the offset. Now, in the onPointerDown method, what we can first do is check the conditions of our activators. Are we allowed to actually perform this event? If for some reason the is dragging flag is also true, that would be a condition for bailing out early. Now let's set those two fields. The offset is going to be where we started our drag. And then let's turn the flag on. Now let's actually capture that pointer. What this does is when the target captures the pointer, all the pointer events are sent to that element, regardless of which element is under the pointer. We can also stop propagation on this event because we don't need other elements in the tree actually trying to handle this event. The target of the manipulator is going to do the handling. Now, this manipulator would work on any visual element, but in our case, the target is going to be the inventory panel. Let's move on to the next method here for onPointerMove. This one's actually pretty straightforward too. Let's start with some basic guard clauses. If we're not dragging, get out of here. If we haven't captured the pointer, get out of here. We'll bail out early. Otherwise, let's actually move this target around. Let's figure out what the delta is between the local position of the event and the offset, and we're just going to apply that to the target's transform position. Then we can also stop event propagation here as well. The final handler is just about as simple. Let's have some guard clauses here at the start. So can't stop manipulation is kind of the inverse of can start manipulation. So if either of those were not true, let's get out of here. Otherwise, is dragging becomes false. And then we can also release the pointer from the target and stop event propagation again. We're all done with the drag. So that's a little bit more straightforward than our drag and drop for the slots, right? But here we can just apply it to one visual element. The slots definitely had a lot more moving pieces. But how can we actually get this working on the target? Well, let's jump over to the inventory view again. And it's simple because we already have an extension method for this. Right where we're creating our inventory, we can just chain it again with the withManipulator extension method and add a new panel drag manipulator to the inventory. That's all you have to do. Well, other than test it out, of course. Let's go have a look. If I reload the domain and press play, check it out. I can grab it by just about anywhere where there isn't a slot filled and drag this thing wherever I want. If I grab a slot, of course, that's going to take precedence. And that all works just the way I expect. So perfect. I'm happy with this so far. So I hope you learned something, or maybe more than one thing new today. We're going to continue this next week where we dive into the controller and the model of this inventory system. All the code for this project will be linked in the description, as well as the assets that I've used. Feel free to post in the comments if you have any thoughts or questions or something you want to see in the coming weeks. Feel free to join in the discussions on our Discord server as well. And if you haven't done so yet, hit that like button, subscribe, and hit the bell so you don't miss next week's episode. I'll see you there.